Welcome to another episode of Earth is Our Home with Dr. Thomas Blaine. Today he's going to be looking at we are on the throes of an El Nino, so stay tuned. Welcome to another episode of Earth is Our Home with Dr. Thomas Blaine. Dr. Thomas Blaine is an associate professor with the Ohio State University Extension Program. It seems to me that when we started Earth is Our Home several years ago, we were in a major La Nina weather pattern. And Tom had been explaining why that significance of the La Nina has affected our weather. Having read some recent articles that El Nino is now starting to come into play. And we're going to have Tom talk about how that is going to affect not only us, but all of the United States and the world. So welcome, Tom. It's great having you here.
Great to be here. This is a really exciting time because, we've done a lot in Earth is Our Home on global climate, how the global climate engine works and so forth. And you can't really understand how the global climate system works without understanding a number of things: the jet stream, the trade winds, the Coriolis effect, and the Southern Oscillation, which also is known as ENSO, El Nino Southern Oscillation, which is the difference between El Nino and La Nina, the temperatures in the equatorial Pacific Ocean. What's interesting is we've been in the midst of an extremely strong La Nina since before we started Earth is Our Home back in early 2021. And last summer of 2022, we did a 3-part series called Nina Rules the Roost. And I think we're going to put that down there so people can go back and watch that. La Nina Rules the Roost. Well, I told you how that was influencing not only global climate, but the global temperature data. And it was giving some impressions about temperature data that were a little bit misleading. And that when El Nino came back, all that would change. Well, lo and behold, here we are in June of 2023. We're in the midst of a flip, and oceanographers, climatologists, meteorologists started saying way back in February, March, and April, hey, this flip has already started. And it's very early in the flip because these take months to get going. Nobody has a crystal ball, but it looks like we're definitely changing in the equatorial Pacific. So here we are, June of 2023 is beginning. And what we're going to be doing here is talking about the transition that we just started from a La Nina to an El Nino. This is very, very important. I know sometimes it's hard for people to understand that, but what happens in the equatorial Pacific does not stay in the equatorial Pacific. It influences climate all around the globe. And we've done a lot of programs, Patrick, on El Nino and La Nina. People can go back to the Earth is Our Home playlist and scroll down and see all kinds of episodes on El Nino and La Nina because we've done so many. But probably the most important one that I would like to point out now is the one from a year ago that was a 3-part series, 3 half-hour programs on La Nina Rules the Roost. And the reason we did that was because we've undergone a major shift over the past few decades where the strong El Ninos ruled the roost in the late 20th century to La Nina ruling the roost in the early 21st century. And why does that matter? Well, one of the things, it has implications for global average temperature trends. Okay, that's one thing. So, in other words, La Nina tends to hold global temperatures down. And when you look at what's happened in the last few years, the global warming trend has backed off a little bit. Temperatures haven't gone up as much as a lot of climatologists expected. That led a lot of people to say, well, global warming has paused. But it really didn't. It really didn't pause. What was happening was a very strong La Nina started several years ago, right about the time the COVID pandemic started, around November of 19, January of 20. That strong La Nina started, and it's persisted. And here we are in early to mid 2023, and we're beginning to see a flip. The Southern Oscillation is bringing us an El Nino to replace one of the strongest and longest lasting La Ninas in recent history. So here's a graph that shows what the information was based on when I said La Nina rules the roost. And that goes all the way out, Patrick. That's got the April 2023 data out, way out to the far right. It's all blue since about the time the pandemic started. The blue are La Ninas. Look at those La Ninas. Now, again, if you want to go back and review what La Nina is versus El Nino, you can do that, and I encourage you to do that. But if you notice on the left-hand side from the late 70s to about the late 90s, there was more red. There were more El Ninos. That means the water in the equatorial Pacific was very warm, and it released a lot of heat into the atmosphere and warmed up the planet. Since that time, we've had more La Ninas. That means the equatorial Pacific Ocean temperatures have been low, relatively speaking. They've been low, especially since 2020. They've been low. And that releases cold air into the environment, which circulates around the planet and cools the planet. Here's a depiction during a La Nina. Blue is colder than average water. Orange and red are areas of water that are warmer than normal. So I'm going to ask you to look at the equatorial Pacific off the coast of Ecuador and Peru and going out west toward the Philippines, Indonesia, Australia. Look at that giant amount of blue. That's essentially the pattern we've had for the last 3 years. Now, that's a lot of water because there's, the Pacific Ocean, of course, is by far the largest ocean in the world. And at the equator between the Americas and Asia is a very long way. So we're talking about an immense amount of water there. And when its temperature changes, it plays a huge role in distributing heat or cold around the planet. And so, if you're following global temperatures, like a lot of us are, because we're interested in seeing, you know, how fast is global temperature changing and so forth. This is a key, because climate change, to the extent that it's happening, is the result of warming. And so if we want to know what's happening with global temperatures, we look at those temperatures, but we need to look at the southern oscillation, that is the cycle of El Nino and La Nina, because it plays a big role. Now, we had that blue patch out there like that for about 3 years. But as recently as April of 2023, scientists who measure water temperatures in the equatorial Pacific began to report that the magnitudes of the La Nina indices were moving very quickly into neutral territory. And they even began to predict that by late in this year, we would be in El Nino conditions. You see how we've been in that blue. If you go way down there at the bottom, you'll see that that was in 2022. That's when we did that La Nina Rules the Roost, because we were down at the strongest portion of the La Nina. But notice since then, if you can see those steps, climatologists follow that, and then they make their predictions, because once that gets going, it's kind of hard to reverse it. And this is what they're expecting, Patrick, by late in the year. This one is from 2015. If you look at this, it's a satellite image dated 18 September 2015, when we were in the midst of one of the strongest El Ninos on record. And look at that in the equatorial Pacific. The winds have reversed, and the warm waters from the Western Pacific are now moving east here in this one from 2015, and bringing very warm water toward the Americas. That releases heat into the atmosphere and raises global temperature. This is what they're predicting. Again, this is from 2015. We're not there yet. We are lucky because we're in the transition period right now. The May numbers and the April/May composite index will be out middle of June, and we are expecting it will continue to step up. Now, just to review, the El Nino is when warm waters are flowing from the Western Pacific back toward the Americas. La Nina is when cold water is flowing from the Americas out west. Now, if you want to just review a minute, why does the water tend to be cold off the coast of the Americas? It's because the oceanic currents. In Peru and Ecuador, the current is bringing water up off Antarctica because it's a counterclockwise flow in the southern hemisphere. Counterclockwise, southern hemisphere. So water comes up off Antarctica, then it moves out across the equator. It's cold, even though it's at the equator. It's very cold water because it's been near Antarctica. The longer it stays at the equator, though, and keeps going out there, the warmer it gets. So by the time it gets out near Indonesia, it's very warm water. But when it's moving in this way, most of the equatorial Pacific is cooler than normal, and that means La Nina. All right. Another thing is that the water off the coast of California and Baja California, Mexico, that water's cold also because, again, in the northern hemisphere, the ocean currents are clockwise. So that means that current off the coast of California is coming down from Alaska. Cold water's coming from the north, from the near the Arctic, and cold water's coming from the south. It's South America, so that off the western coast of America, the ocean waters tend to be cold. When the wind's blowing out, you've got La Nina. It cools the temperature of the planet. When the winds reverse, as they're doing now as we speak, you're bringing that warm water back from Asia toward the Americas. That's El Nino, and we're right in between there now. So as this happens, we're talking about a new normal. One of the things that I told you was that El Nino is associated with a lot warmer temperatures. And look at that giant package of warm air that extends pretty much from the Aleutian Islands up into Alaska, all the way down into Western Canada and the Northwest United States into the Great Plains. It's a pretty big dome of warm air. And as a result, global temperatures, remember, we're measuring the temperature of the entire globe. At the equator, it's warmer. It's even warmer up near Alaska. So you're talking about quite a lot of the earth warming up. As opposed to a La Nina pattern, this is what we've had for the past 3 years, where the jet stream moves in this way, allowing cold air to come from the North Pole all the way down to the Great Plains. That's a pretty big dome of cold air. This is what we've had. And this is what we're moving to, according to those who study the equatorial Pacific. As you can see, the equatorial Pacific's not even really in this map. But yet this map differs from that map because of what's going on at the equatorial Pacific. And if you want to go back and look at the climate engine that we did several episodes back in the spring of 2021, we've got climate engine. Go back and watch those videos at Earth is Our Home, and we show why these are related. So what is liable to happen if this follows the patterns of 1997 and 98, the pattern of 2015 and 2016? We should see a very rapid increase. That's a full degree Celsius in global temperature. Now, remember, when we plot out the trend from the pre-modern times to now, the total warming has only been about 1 degree Celsius. That's 1.8 degrees Fahrenheit. That's the overall trend. But within the trend, there are trends. There are waves around that. And so we're likely to see an increase in monthly temperatures between now and, say, a year or 2 years from now of an entire degree Celsius, 1.8 degrees Fahrenheit. Okay, that's not going to be the long-term trend, but it's going to be a short-term trend. If you look at what happened after the La Nina ended in 2012, you'll see there's a monthly temperature down there in 2012 that was 0.4 of a degree below the average. 0.4 of a degree below the average. And by the early part of 2016, there's a month that's 0.7 above the average. So you have some people kind of, if they want to mislead you, they could easily say the global temperature has risen 1.1 degrees Celsius in just about a 2 to 3 year period. And they would show that. Okay. But the reason that happened, the reason we were so cool then in 2012 was because we were coming out of a La Nina. And the reason we got so warm in 2016 was because we were coming into an El Nino. So that accounts for those extremes. That's not human. You know, a lot of people say, well, isn't it true that there are natural things that influence global temperature? Yes, there are. What I'm saying is this overall trend from 1979 to 2023, the overall trend that you see is caused by humans. But somebody can just do what's called cherry picking and pick a month here, in this case, early 2012, and then January of 2016. And let's see if those do in fact correspond, Patrick, to La Ninas and El Nino. And as you can see, they do. Look what happened right before 2012. Look at the 2010, 2011, 2012. Look at all that blue. It's not a mystery why 2012 was so low in the temperature. If people back in 2012 were saying global warming's not happening, the current global temperature is cooler than average. It was cooler than average because of the La Nina. And then it jumped up. If an alarmist is saying, my goodness, we've raised 1.1 degrees Celsius, that's almost 2 degrees Fahrenheit between 2012 and 2016. Again, look what happened going into 2016. The gigantic El Nino. So from that dip below, notice that parallels pretty much exactly what happened. This index parallels almost exactly what happened in the temperatures since then. And it's the same on the way down. Let's go back and look, Patrick, at 1998. We were at a record high temperature in 1998 at 0.6 of a degree Celsius above the average. And by 2000, we were 0.4 below. That's a full degree Celsius. It's like a century of warming, only cooling. So that wiped out a century of warming, that cooling. But it's an illusion, because I guarantee you, before we go back and look, we're going to see that 1998 out to 2000, we're going to see what we expect to see. And there you go. Look around 1997 and 98, that giant El Nino, when it was so warm at the equatorial Pacific, caused by the location of the Southern Oscillation. And look at what happened out to the year 2000. Temperatures plummeted, but they didn't plummet because of humans. They plummeted because of the Southern Oscillation. And the same thing has happened more recently. The reason that we've been below trend here in the early 2020s, the reason we're below the trend, we would ordinarily be at this place up around 0.4, 0.5 degrees, but we're below that is because La Nina has been ruling the roost. So what I'm asking you to look for is that about a year from now, if we do go into this El Nino, as meteorologists and oceanographers are expecting, those blue dots will be up at the very top. We're going to break records. We will be up around 0.7, 0.8, 0.9 on this graph, up near the top of the graph. We're getting ready to see a very significant rise in global temperatures that will indeed remind us that, yes, we've got fluctuations as we're going, but the overall trend is global warming. During any given El Nino now in the 21st century, it's warmer than the El Ninos were in the 20th century, and the La Ninas are warmer than the La Ninas were in the 20th century. And so that's what's happening with these temperatures. And I think that it's going to be fun because we're going to be able to kind of go in real time and follow this transition from La Nina to El Nino here in 2023.
Let's take California. It's been hit by a lot of major droughts and major fires. And I know in Texas, major drought and water problems. What does that mean for us?
Yes, if you look here, the La Nina pattern tends to put the southern United States at risk for drought. Okay, so over the past 3 years, we've read a lot about drought in Nevada, Texas, and some other places. But again, if you look at the typical La Nina pattern, and that's what's ruled the roost in 2020, 2021, 2022, that's what's ruled the roost. So it tends to make the South, especially the Southwest, more prone to drought. Whereas when we come into El Nino, it generally means there's quite a bit of rain in the South. You can see storms come on shore, even at Baja California, into New Mexico, Texas, all the way across to Florida. And we're kind of in the middle of this. You know, our weather can fluctuate in a lot of ways with these, but the places that are impacted the most, you can see there, the Southwest and all those places where they've had drought. Texas should get a lot of relief from this El Nino. And California already got some relief this past winter due to some kind of freakish weather events. And that was certainly good news for California. As you can see with La Nina, the borderline between the wetter and the drier is right in California in La Nina. So it can kind of go either way. And this past year, they've made up for some lost time on precipitation.
We're talking with Dr. Thomas Blaine. He's an associate professor with the Ohio State University Extension Program. Tom, I look forward to learning more about how El Nino might affect our weather. Thank you.
Thank you, Patrick.